Hello everyone, my name is Hüseyin Uygar Kirkiz, and in this video I will be presenting my Physics 101 experiment titled Investigation of Friction on an Inclined Plane Measuring the Kinetic Friction Coefficient. In this experiment, my goal was to understand how the acceleration of a block sliding down an inclined plane changes with the angle of the incline when friction is present. According to Newton's second law, the net force acting on a block along the incline is given, and this leads to theoretical acceleration. This relationship tells us that as the angle increases, the component of gravity pulling the block downward gets stronger, while friction becomes relatively less important. To test this model, I used an adjustable inclined plane, a wooden block, a ruler, a protractor, and a stopwatch. I first measured a fixed distance of 100 centimeters along the incline and marked it. Then, for each selected angle, such as 15, 20, 25, 30, and 35, I placed the block at the top and released it from rest without giving any push. For each angle, I measured how long it took the block to slide down an 100 centimeter distance. I repeated the timing 3 to 5 times to reduce random error and calculated the mean value for each angle. All of these measurements were later used to compute the experimental acceleration with the formula, which is appropriate because the block starts from rest and moves with nearly constant acceleration. Using the measured times, I calculated the acceleration values for each angle and compared them with the theoretical prediction. I also computed this for each angle, because plotting this gives a straight line whose y-intercept equals minus friction coefficient. In other words, the slope and intercept of this graph allow us to experimentally determine the kinetic friction coefficient between the block and this plane. This method reduces error and gives a more reliable estimate than calculating kinetic friction coefficients separately for each angle. As expected, the block's acceleration increased as the inclined angle became larger. This matched the theoretical model because the parallel component of gravity increases with angle while the frictional force, which depends on the normal force, becomes weaker. From the linear graph, I used the y-intercept to determine the kinetic friction coefficient. The experiment successfully demonstrated that the motion of an object on an incline can be predicted using Newton's laws and that friction plays a measurable and consistent role. In conclusion, this experiment verified the theoretical relationship between acceleration, incline angle, and kinetic friction. By analyzing the